Hello students, this is Abhishek Kumar. I am the physics faculty associated with askIITians for last 4 years. So in this session we are going to talk about the chapter thermal properties of the matter. Within that we'll deal with the topics like what exactly is the heat, what is the temperature, then we'll try to differentiate what exactly is heat and temperatures are, then we'll move on to the measurements of the heat and the temperatures, and then we'll see what are the scales that have been devised and what are the basis for the conversion between these three. So let's start with the topic. Hello everyone. Today we are going to deal with the topic thermal properties of matter. Till now we have dealt with the physical properties of the matter, the chemical properties, the mechanical properties of the matter. Today we are going to deal with the property of the matter that will deal with the transfer of the heat, its related properties like temperature and the various phenomena of heat transfers. So let's start the topic. Now the various topics in this are going to follow this order. First we'll introduce what exactly is this temperature, the thermal properties of the matter. Let's introduce what exactly is this heat and temperature. Now temperature is a measure of the hotness of the body. Now this is a definition that is very basic to us. We have seen this definition in our primary classes, that temperature is a measure of hotness. Means this is a way of measuring. Means the temperature is something that assigns a particular value by which you can tell how hot a body is. That means if someone tells that a body is 50 degrees Celsius, whereas this is the unit for the temperature, we'll see, and then another body has 100 degrees Celsius. What it means that by comparing this 50 and 100, I can tell that since this 100 is higher, so that means it has higher temperature. Okay. So the temperature is simply a measure of hotness. We have defined a way, we have defined a parameter like we define weight for measuring how heavy it is. Okay. The same way we have defined m into v for measuring the momentum which actually gives us the force. Similarly, to measure how hot a body is, we have defined this thing that is called temperature. Along the way we will find out why blacksmiths heat the iron ring before fitting on the rim of the wooden wheel. We'll see how this expansion and contraction, this leads to all these interesting phenomena that we see in our daily life, how it helps in doing all these things, and why the wind at the beach often reverses direction after the sun goes down. You may have been familiar with the land bridge and the sea breezes. Now we know that these two are flowing in opposite direction. Land breeze flows from land to sea, and this is the reverse of it. Okay, so why this happens? So this happens due to heating and cooling. So we'll see how all this phenomena are happening in our daily life. So now the next thing is definition of the heat. We have seen what exactly is temperature. Now we'll see what exactly is heat. Heat is a form of energy. What it is? It is a form of energy that is transferred. Why I am encircling this is that this transfer is very important for the definition of heat. There is a general confusion or there is general unawareness on what exactly is the heat, what I have found from my experience. So we'll deal with this definition for once and we'll clear it for once and for all. So this is transferred, it is a form of the energy that is transferred between two or more systems or a system and its surrounding by virtue of temperature difference. Okay, now this, why I emphasized on this word transferred is that if you have this body and this body, suppose this is hot and this is cold. Okay, so what will happen? We know that the hot body loses heat. So let us assume that we connect it by something. There is a way, maybe a rod or something. That is the only way of transfer of heat, because the hotter one will lose heat, colder one will gain heat. So normally what happens? It may gain heat through this atmosphere, like flowing of radiation something, or it may be connected, or you may put these two things in contact and then the heat may be transferred. So let us assume some method of conduction. So this rod simply shows that there is some method of conduction. Now what is heat? Heat is the energy only when, be very clear, it is the energy only when it is being transferred. It is being transferred, means in the way of movement only this is heat. It is not called heat when it is in the hot body, and it's not called heat when it reaches the cold body. It is called heat only when it's in the midst of transfer of heat. That is heat. Then what is that we call it when it's in the body? When it is in this body, we call it internal energy. And so is it called when it is in the cold body. So there is no thing like this much heat is contained by a body. Okay, this much heat is contained by another body. This body contains more heat than another body. These are all wrong statements. What they contain is the internal energy. Heat is only when, for the time being, when it is being transferred. So heat is the energy in transit. It's only the energy in transit, nothing else. Be very clear with this definition. Okay. Now the SI unit of heat energy is joule. It's named after the scientist. Honoring Joule, we named him Joule J, capital J. While SI unit of temperature is Kelvin. For the temperature is Kelvin, again is the name of the scientist. Degree Celsius is a common unit used for temperature. Now in our daily life, you may have seen that the thermometer that you have, normally it has degree Celsius as the unit. When an object is heated, many changes take place. Its temperature may rise, it may expand or change its state. We will study all these effects in our following slides. Now the measurement of temperature. Since I told you there are three scales. There is a Fahrenheit scale that you may be aware. Then there is a Celsius, the most common, and then there is a Kelvin. Now this Kelvin is the SI unit. This is the SI unit. Among the 7 standard units, Kelvin is the one. Now this is the relation by which you can convert between two. This is the, when the temperature is given is Fahrenheit minus 32 by 180, Tc by 100 is Tk minus 273.16 by 100. That means how to convert it? Suppose you have a temperature like 10 degrees Celsius. I ask you, what value will it be in Fahrenheit scale? So you have to use this relation. You take Tf minus 32 by 180 is equal to Tc by 100. So Tc is 10, here it's given by 100. So this is 1 by 10. This 0 will cancel this. So Tf becomes this, when 18 goes this side, you have 18 plus 32. That is 50 degree Fahrenheit. So 10 degree Celsius is actually equivalent to 50 degree Fahrenheit. So this is how you can convert one into another. You may find it, you may find the Kelvin value from here. For that you will have to use Tk. Instead of using this, you will use Tk minus 273.16 by 100. And then you will get the values in Kelvin scale. Now let us see what exactly is this thermal expansion. Now you have studied in your primary classes that when we heat something, and you may have observed it also, when we heat something it expands. Means it increases its length, breadth, height, everything. Whatever the dimensions are, the physical dimensions, it increases those parameters. So a change in temperature, it causes a change in its dimensions. Now the increase in the dimension of the body due to increase in its temperature is called thermal expansion. Now this property is called the thermal expansion. When the expansion is happening, or the contraction may happen when the temperature is decreased due to heat, it is called thermal expansion. Thermal comes from a word called thermos. Thermos means heat. So thermal expansion means the expansion happening due to heat. It may lead to expansion or it may lead to contraction. It covers both of them. So when it is happening due to heat, we call it thermal. Now here these are the formulas that we will see later on how these come into picture. When only the length is changing, like when you have a rod, then the change in length delta L by L is equal to alpha 1 times T, where T is the change in temperature. It's not the temperature we are talking. Maybe better I should write delta T. So because it's whatever is the change in temperature delta T, from that you will get the change in length delta L. Okay, delta A by A is 2A1 delta T, and this is again delta T. Okay, and what is this alpha 1? Alpha 1 is the coefficient of linear expansion. This is the coefficient of linear expansion whose values are normally given to you. Okay, so let's move forward. So we are seeing here in detail. Now if a substance is in the form of a long rod, what you saw there, if you have a simply long rod, suppose of length L, okay, then for a small change in temperature delta T, suppose now it is at temperature T, you increase the temperature to T plus delta T. What will happen? Its length will change to L plus delta L. Okay. So delta L by L, it is directly proportional to delta T. That's how this thermal expansion is related. That means delta L by L is equal to alpha times delta T. That means the change in length is equal to L alpha delta T. Now what is the change in length? We know it is final length minus initial length. Okay, L alpha delta T. What is this L? This L is actually the initial length. So final length will be this Li is actually the L. So it will go this side, L into 1 plus alpha delta T. So this is actually the relation. From here you can deduce all this. Okay, alpha is known as the coefficient of linear expansion and it is the characteristic of the material. Okay, whichever type of rod is it. When you have steel, when you have aluminium, they will have a different value of alpha. Sorry. So now let's see an example. The density of a substance at 0 degrees Celsius is 10 gram per centimeter cube and at 100 degrees Celsius its density is 9.7 grams. The coefficient of linear expansion of the substances. We have to find out the alpha value. Now if you remember, we had three relations. Delta L by L was alpha delta T. Similarly for area we had 2 alpha delta T, if you remember. Similarly for volume we had delta V by V. Okay, so this is delta V by V. Okay, now from here if you remember we got that the final length is initial length Li 1 plus alpha delta. Similarly you will get from these three relations also that the final volume, this is initial volume into 1 plus thrice of alpha delta T. Similar method, you can see it how it is coming, exactly the same thing, only this 3 was there if you see in these two relations, so this 3 is there. The question says the densities are given, so now we have the relation for the volume, right? But when the temperature changes, we know one thing is there that is constant, it's called the mass. Okay, so if you have to find the relation between density, we have the formula for volume and we know mass is a constant. Now we know that density is mass by volume. Okay, density of this value is mass by volume. That means this implies volume into rho must be a constant. When the temperature is changed, these two things must be a constant, right? So what this means is that the final volume into final density must be equal to the initial volume into initial density, right? So rho f by rho I is equal to, if you see this rho f by rho I, it becomes Vi by V rho, sorry Vf. So what is Vf? If you put this value, we will have Vi by Vi into 1 plus 3 alpha delta T. Vi cancels out. So you have this relation. Now if you see here, you have rho f and rho I, right? Density of substance at 0 degrees Celsius it is this, and at 100 degrees Celsius it is this. Okay, so that means the delta T value, if you find out from here what is delta T, it is 100 minus 0, that is 100. Okay, rho I is 10 gram per centimeter cube, and then rho f is 9.7 gram per centimeter cube. So let's put the values and we will get the answer. So this is this. So if you put the values, what we have here is rho f is 9.7 by 10 is equal to, this is 1 plus 3 alpha delta T, right? Solving this, you will have 3 alpha delta T is 9.7 by 10 minus 1. Okay, okay, see, sorry, your delta T is actually, when you take delta T is 100, your final is 9.7 by this. So rho f, so if I have taken 9.7, this is actually minus 1, right? power is minus 1, not the plus 1. So 3 alpha delta T will actually be minus of this, right? So the value of alpha is 9.7 by 10. So this is 1 minus 9.7 by 10, that is 0.3 by 10 by 3, and this is delta T. What is this delta T? Delta T is actually, you had it 100. So into 1 by 3. So let's make it 3. Simply make it 300. Okay. So now when you cancel these values, this 3 cancels with this. So you have 0.0001. And its unit we know. What is the unit? You can see it from here. Alpha unit is per degree Celsius. So this is the value of alpha. So you have to simply use this relation to put the values and we get the answer. So here we have talked about what exactly is the heat, how the heat is different from the different forms of internal energy that we know, and then we talked about the temperature. Now in the temperature we saw 3 scales like the Celsius, Fahrenheit and the Kelvin scales, and we had the relations between their conversions, and then we saw the numericals on how to apply these equations. In the next part we are going to deal with the specific heat capacity and the calorimetry. So stay tuned for more on Ask IITians.